Hi, boys and girls. Well, today we're going to read a book about a tool that uses forces. Yeah, we're going to read a book about magnets. And magnets are a tool that can provide a push or a pull. So let's find out about the simple science of magnets. And it's written by Emily James. And I can see that this book has photos instead of drawings as the illustrations. All right. The simple science of magnets. And we can see here that iron sand is being attracted to the magnet word. Attraction is a word we're going to be looking at today. Table of contents. So you're right. I'm going to get another wrinkle. Look, I already have lots of wrinkles. So I'm going to get another one. This is awesome. Magic. Magnets. Magnets can make objects move without touching them. When string pulls something, you see it work. So if you have a string or something and you pull it, you can see it working. But you can't see a magnet's power. Magnets seem to move things by magic. Wow, so that magnet is attracting those metal balls. How do magnets work? A magnet has an invisible area around it. The area is called the magnetic field. A magnet can pull things that are in the magnetic field only. Set a paperclip far away from a magnet. So set it far away. Then slowly move the clip closer to the magnet. Suddenly, it will zip towards the magnet fast. The clip has entered the magnet's magnetic field. Magnets can't move all objects. They move only special kinds of metal. Steel and iron can be moved easily by a magnet. Copper and nickel cannot. Neither can cotton, rubber, or plastic. And we can see by the labels in the book, so in a lot of nonfiction text, they will use labels to help share information with the reader. And this says steel. And this one, copper. So the steel is sticking to the magnet. The copper is not, even though they're both metals. Magnets can turn metal objects into magnets. Try this. Hang an iron nail from the end of a magnet. Then touch a paperclip to the nail. What happens? That's something you'll be doing in the classroom. The clip sticks to the nail. The nail has turned into a magnet. Now pull the nail away from the magnet. Does the paperclip still stick to the nail? We are going to find out. North and South poles. Most magnets look like bars or horseshoes. Their power is strongest at the ends. You can maybe see this has an N for north and it has an S for south. North, south. One end is called the North Pole. The other end is called the South Pole. The poles can push as well as pull. And we know push and a pull are a force. Poles that are alike, that means the same. Poles that are alike push against each other. They repel They don't want to be near each other. I repel you. The north pole of one magnet will repel the north pole of another. Opposite poles pull towards each other. They attract. North, south. Oh yeah, let's be friends. I want to be friends. They attract each other. So the iron sand wants to be together between the poles. But over here, it's repelling, it's pushing away. The north pole of one magnet will attract the south pole of another magnet. Earth is a magnet, a big one. Just like magnets, it has two poles. Earth's magnetic poles are not exactly the same spots as the North and South Pole, but they're pretty close. How is Earth a magnet? The rocks inside the planet are made mostly of iron. The iron makes one giant magnet. How do compasses work? A compass holds a needle. The needle is a magnet. Earth's magnetic power pulls the needle up towards the North Pole. A compass needle always points north. Compasses will help people find their way. They show directions. Sailors use compasses to go across the ocean. Airplane pilots and hikers use compasses too, so they know where they are and where they're going. The first compasses were made from magnetite. Magnetite is a black mineral. It is a natural magnet. A piece of magnetite is also called lodestone. Early Chinese compasses used lodestone. They were carved into the shape of a spoon and sat on a flat plate. The handle of the spoon always pointed which way? You got it, north. Magnets all around. Today we use magnets for many things. Doctors use magnets to see where people are hurt. An MRI machine holds a powerful magnet. It helps make pictures of inside your body. Magnets help junkyard workers lift tons of metal. The huge magnets can move cars just like they were toy cars. And that's an electromagnet. They can turn it on and off. Fans spin, refrigerators hum, burglar alarms ring. None of these things would work without magnets. Neither can TVs, radios, or phones. Magnets hold up pictures. They hold up signs. Credit cards use magnets to help people buy things. So there's a lot of magnets around in this world that we didn't know had magnets. The world would be very, very different without magnets. Magnets make our lives easier and safer. They make our lives more fun too. Move it with magnets. And there's a lot of things that we can do with magnets that we'll be trying out. And here's our glossary, and I'll read more. So, the book told us that magnets are attracted to metal. So I have a couple of items here. Because you shouldn't always believe what you read. You should find out more information. Either try testing it yourself or read other material to see if it supports what you read the first time or if it contradicts. That means it doesn't agree what you read the first time. So let's find out. In my hand here, I have a magnet, just a plain handled magnet. The magnet part's up here, and I have a wooden stick. Well, let's see. Does the magnet... Nope, wooden sticks don't stick to my magnet. Let's try something else. How about my metal ring? This is a curtain clip that I use to hold curtains. It's made of metal. Let's see. Yes, this one does stick to the magnet. So in this ring, there must be iron or steel. Okay, let's take the clip off. How about my marker? Yup. No matter what I do, it doesn't want to stick to plastic. How about my paper clip? We're always using paper clips in the classroom. Yes. So inside the paper clip, there must be iron or steel. Now, how about my clothes peg? The one like you use to make your cat in a hat puppet. I wonder if that will stick to the magnet. What do you think? It's made of wood. It's got some metal on it too. Let's find out. Well, it doesn't stick to the wooden end. But how about if I try it from the side? Yes, it has enough metal on the sides to be able to hold the clothes peg. So, go around and scroll down and see what your job is for today.